much for inviting me to be here, and I apologise for not being here for the last 2 days because, in fact, this medal that Andrew just mentioned was awarded last night by the Governor of Victoria, and I'm not allowed to stand up the Governor. So what I'm going to do is talk again about climate change and the Anthropocene, and part of what I'm going to talk about is the sort of three bears stories that you'll hear there, and whether we have a just right planet that we can look forward to, or a just right environment that we can still look forward to, or is that option gone? But given the context of the three bowls of porridge, I'm actually going to talk about three stories. The first story is a good news story, a successful response to human impacts in the Anthropocene. We've fixed a problem, or we're in the process of fixing a problem. The second story is we're in the middle of it. It's about climate change, and I'm not sure if it's a good news or a bad news story. The third story is a horror story, and it is being talked about as if it was a good news story. But it is a horror story, and this is the story of geoengineering. And as far as I can tell, no one's talked about geoengineering the climate system yet. And I'm going to try and cover all of those stories in the next 30 minutes or so. So let me start off when I get this. Oh, I've got to turn it around the correct way. That will work. So the first thing I'm going to do is, I know you've heard from Will Steffen about climate change already, and I know you've also heard from Leslie Hughes, both of whom are very good friends of mine. I'm not sure that they showed this graph, and let me point just here is the best estimate of the 2015 temperature. It is way above all the previous year's temperatures, globally averaged, annually averaged, for the last 150 years. Important thing to recognise is, yes, that is partly due to the fact that this year is an El Nino year, but the best comparator for 2015 in terms of global temperature is not the one that many people talk about. Many people talk about 1998 as the previous hottest year due to El Nino. That was the year after the El Nino. So we're looking for a year like 1998 in 2016, not 2015. 2015 is just normal climate change with a little bit of El Nino. So that's not the good news, but this is the good news. Stratospheric ozone depletion was identified as a global issue due to human interference with the environment because people were using ozone-depleting chemicals, chlorofluorocarbons, and chemicals containing bromine, both for propellants, for refrigerants, and for firefighting. They were believed to be incredibly safe. They were. They don't react with anything, except when they get decomposed or broken by high-energy ultraviolet radiation, they split. The chlorine becomes activated, that destroys the ozone layer. This led to regular stratospheric ozone depletion globally, as well as in the southern hemisphere spring over Antarctica. And you can see we still have Antarctic ozone hole in the graphs that I show. This is the time evolution of the Antarctic ozone hole. The thick black line on the screen is what's happened this year. It was a long-lived ozone hole this year. It is still existing. But just so you don't believe everything in the newspapers, the ozone hole does not affect Australia directly. Stratospheric ozone depletion is not the cause of the increase in skin cancer in Australia. That's because people run around with less clothes on than they used to. People used to wear hats, long-sleeve shirts, long-sleeve pants in summer in Australia, and in the 1960s, that became unpopular. And what became popular was going out in the sun. That has caused the massive increase in skin cancer in Australia and New Zealand. It's not the ozone hole. And the ozone hole, as you can see on these maps, is a long way from Australia. In fact, there's an ozone mountain, which you never hear about, between Australia and the ozone hole. So, what's happened globally? So, what you see up the top is the long-term variations in global ozone and the minimum in Antarctic ozone. It declined substantially from 1980 to 2000, and then it turned around because of the Montreal Protocol on ozone-depleting chemicals, which controlled the amount of use and production of ozone-depleting chemicals around the world, particularly in developed countries, but it also included developing countries. And what has happened in terms of those ozone-depleting chemicals, I just said what exactly that said. The Montreal Protocol was established in 1987. It controlled ozone-depleting chemicals initially in developed countries and then in developing countries. And the goal was for the levels of ozone-depleting chemicals to return to pre-ozone hole levels or pre-1980 levels by around 2040 globally and around 2050. This is what's happened to the concentrations of those chemicals. They've gone up and then they've fallen. Production and use of CFCs and bromine-containing chemicals in firefighting is essentially zero. Methyl bromide is still being used, methyl chloroform is still being used, but they're relatively smaller. CFCs have an incredibly long lifetime, so even though their production and use has gone to zero, there is still some leaking from old fridges, and it takes a long time for it to be destroyed through the atmospheric processes. But we do expect it to return, and what we're looking at is how long it will take to return to 1980 levels, and that's about 2040 to 2050, and eventually, maybe by the end of this century, it'll return to pre-1950 levels. The ozone hole and the ozone layer is recovering. That's a fantastic good news story. There's a really second, good news story as well. We hear a lot about the Framework Convention on Climate Change, and I'm going to talk about that. Will Stefan talked about that. That's why countries are meeting in Paris to talk about controls on emissions of greenhouse gases. But in fact, the ozone-depleting chemicals are also greenhouse gases. They're very potent greenhouse gases, and they're not covered under the UN Framework Convention on Climate Change because they're already covered under the Montreal Protocol. They're phased out. So we can compare what the effect of the Kyoto Protocol on slowing down global warming is to the influence of the Montreal Protocol, which its principal objective was solving the problem with the ozone layer, what its effect is on global warming. Let's come up here first. This is the global variations in greenhouse gas emissions from fossil fuel burning and land clearing. It's the carbon dioxide and other greenhouse gases. This is just from fossil fuel burning, but you can look at that, and it's up at 30 billion tonnes before 2000. Current level is up in 2010 at more like 40 billion tonnes when you take into account all the greenhouse gases. The effect of the Kyoto Protocol is this magnitude, a 2 gigaton reduction from what it would have been. This is the effect in terms of the reduction due to the Montreal Protocol. 10 billion tonnes of carbon dioxide equivalent. The Montreal Protocol has been 5 times more effective in slowing down global warming than the Kyoto Protocol. I would guess that no one in this room has heard as much discussion about the Kyoto Protocol, about the Montreal Protocol because it was easy to solve than about the Kyoto Protocol or the UN Framework Convention. So that's a good news story, but don't say it too loud or there'll be just as much debate about the Montreal Protocol and how it involves global warming. So just keep that quiet, please. Now we come to the UN Framework Convention, and whether this is a good news story or a bad news story depends on what happens in the next 3 days. There will not be agreement in Paris tonight. There may not be agreement in Paris by Sunday. Who knows? We'll wait and see. But it's important to understand the objective is really clear. The objective is stabilisation of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous human interference with the climate system. It's part of the Anthropocene that humans are modifying the atmosphere, not just by ozone-depleting chemicals, by burning fossil fuels and dumping the waste product, carbon dioxide, in the atmosphere, or land clearing and other industrial activity. The important thing, and not many people know about this, is Article 3, which gives guidance on the responses. And Australia and 192 countries ratified this way back in 1994. The agreement says parties should protect the climate system on the basis of equity. Politicians find equity difficult. Children at birthday parties find equity difficult when you're sharing a chocolate cake. But when you do that and share a chocolate cake, you give the same amount to each person. That would seem to be an equitable way of distributing carbon dioxide emissions. And just to provide guidance, it says developed country parties should take the lead in combating climate change, not developed countries should wait until India and China reduce their emissions. So let's look at some views from different political leaders. Ban Ki-moon looks at climate change in the context of its impact on development. The impacts are greater in developing countries, even though developed countries are the major contributor to the increase in greenhouse gas emissions. Barack Obama looks at this in terms of intergenerational issues. The impacts are long-term and will affect future generations more than the present. And Tony Abbott almost got everything right in this statement. He got the tense wrong. He should have said coal was good for humanity, but he did say coal is good for humanity. What he meant to say was coal was good for humanity because it did provide a fantastic energy source to power the Industrial Revolution. But now we know of its waste products and we have a better solution. And just like in the Stone Age, where we still have plenty of stones around, we can end the coal age before we dig up all the coal. I think. Of course, scientists have been seeking to understand the causes and provide higher and higher confidence assessment of the causes of climate change. This is not my cartoon, but it's a classic, because it talks about the role of the Intergovernmental Panel on Climate Change. Its first assessment came out in 1990, it was formed in 1988, and it provides the science input to governments and the science input to the UN Framework Convention. In 1990, conclusion was, well, climate change probably is going to be a problem. The next assessment in 95 is it's definitely a problem. 2001, yep, we really should do something about this. And most recently, we've really checked everything, we've done as much as we can, and wait a sec, is the microphone working? Is the communication to the politicians working? It's clear that it isn't. Although you could argue that things are much better. These are the key conclusions. The climate system is warming, there's no doubt. Human influences are the dominant factor. It's virtually certain there's going to be more hot extremes, like the record number of very hot days in Sydney in November, and more extreme precipitation events, like happened in the UK, set a new heavy one-day rainfall record last weekend. There are more heavy rainfall extremes, there are more hot extremes and fewer cold extremes. Where are we heading? Well, we have a choice between two planets. We have a choice between that very red planet with temperatures warming by about 4 degrees above the level at the start of the 21st century, or we have a planet which the governments have agreed to limit warming to, and that agreement is to reduce greenhouse gas emissions so that temperatures don't warm above 2 degrees. But when they do a risk assessment, they're making an assessment in terms of emission reductions which is either a 50-50 chance of avoiding dangerous climate change, 50-50 chance of exceeding 2 degrees, or a 2/3 chance of staying below 2 degrees. And I'm not aware of anyone who would get on an aeroplane with a 50-50 chance of it crashing. But we're taking a 50-50 chance of dangerous climate change on the only planet that we know is habitable for humans. That's a really strange risk assessment. None of us would take that personally, but we're allowing our politicians and our government to take that risk for us in Paris. It's a really weird sort of assessment. So what are the impacts? Well, many of us are feeling those impacts. As I said, more hot extremes, fewer cold extremes, increases in sea level, health impacts, and we're going to hear some of that. Displacement of people due to sea level rise, coastal flooding. Sydney Airport will be underwater due to climate change. Probably not in the next 10 years, virtually certainly not in the next 10 years, almost certainly at the end of this century. Not underwater every day, but regularly underwater due to storm surges and due to sea level rise. Brisbane Airport will be underwater sooner than that. Brisbane Airport had to be closed in the Brisbane floods because of sea level rise and storm surge in the 2011 floods. The choices we have are what we're going to do in terms of greenhouse gases. I know Will's talked about this already, but we have to decarbonise. We have to come down on this blue trajectory. That means decarbonising the global economy before 2080. It means, because developed countries have the highest emissions and developed countries have to take the lead, decarbonising the Australian economy before 2050. That is inconsistent with digging up coal and flogging it to other countries, unless you're a politician. Will, I think, talked about the carbon budget. Carbon dioxide emissions add to the carbon dioxide concentration in the atmosphere, and the natural processes to remove carbon dioxide from the climate system, from the atmosphere long term, are very, very slow. 10% of the increase in carbon dioxide in the atmosphere over the last 100 years will still be in the atmosphere in 10,000 years if we only use natural processes to remove it. This is a really long-term problem. And every time you add more carbon dioxide, it takes 10,000 years to remove 90% of that. So, what we now know is that it's the cumulative emissions of carbon dioxide that determine long-term global temperature change. The longer we wait to reduce emissions, the hotter it will be. And any delay in action to reduce emissions is a conscious decision to make the problem worse. It's usually not framed that way, but we know that's what happens. We also know, with existing technologies, and I think Will talked about this as well, that we can solve this problem. We need to rapidly reduce greenhouse gas emissions. We know we need to produce low emission energy supplies. We also need to change behaviour and to slow down global population growth. But the most important thing is to slow down consumption. To slow down, not economic growth, just consumption. And we can do that easily. But most companies don't want us to. The easy way is ban advertising. But that's not going to be very popular either. This is the choice. The planet on the right-hand side is a planet that no humans have lived on. It's a planet that we haven't experienced, but it is a planet that this planet hasn't experienced for more than 10 million years. That's business as usual. The planet on the left-hand side is what we have for about 2 degrees of warming. It's habitable, but it's different. It's hotter with more hot extremes, and there are still major impacts. Some people are saying that we can make choices and avoid reducing greenhouse gas emissions by doing something else. And I'm going to talk about that in just a minute. But let me finish this section with what the scientific assessment was of what the choices are. We know humans are influencing the climate. We know that the more we emit greenhouse gases, the greater is the risk of severe disruption, the more we impact the Anthropocene. We also know that we can solve climate change for a modest economic cost and build a prosperous and sustainable future if we want. And we is everyone. It's not clear that it's the mining companies in Australia at present. But let's look now at the alternative. There is a solution, and I treat that word very cautiously, a solution that is being suggested in some circles. Oh, well, forget that cartoon. This is what's happening in Paris. They just got the label wrong. This was a previous conference of parties in Poznan in 2008. 7 years ago. They want to save the planet, but let's delay it. Remember, delay is a conscious decision to make the problem worse. I'm going to talk about geoengineering. Geoengineering is artificial manipulation of the physical, chemical, or biological aspects of the Earth system. It's the crux of the Anthropocene, or maybe it's the worst part of the Anthropocene. People choosing consciously to modify the Earth system to try to solve one problem: climate change. And it's a bit like fixing the symptoms of the disease without fixing the cause. And you fix the symptoms either by removing carbon dioxide artificially from the atmosphere or by reflecting sunlight. The removing carbon dioxide removal, there are a number of different ways to enhance carbon dioxide removal from the atmosphere. Solar radiation management sounds fantastic. Management tool. The goal is to reduce some sunlight, so there's less sunlight and that offsets the warming due to increases in carbon dioxide. And then you don't have to reduce the carbon dioxide. It's a little bit like introducing cane toads in Queensland to fix the problem with the cane beetles. Let's see what might be, let's come around this way. What might be. So, carbon dioxide removal, a number of options, including fertilising the ocean with iron filings, or extracting carbon dioxide using trees, or other factors like that. It can work, simple tests, and it probably is less dangerous than the alternative, which is solar radiation management. Solar radiation management, either increasing the reflection by putting particles in the stratosphere, the upper atmosphere. Volcanoes do it. They inject dust and particles in the upper atmosphere, and it cools the climate system for a year or two. You have to do it a lot and continuously, and it can cool the climate system. It's tested every time a volcano goes off, and it works. Well, a big volcano. You can't really put giant reflectors in space because you have to reduce the amount of solar radiation by about 1%. That means you would have to cover 1% of the Earth's surface or above the Earth, reflectors in space, with a lot of aluminium foil. And 1% of the area of the Earth is more aluminium foil than we produce every year, and you can't get it up into space without burning a lot of greenhouse gases to get it up there. So that doesn't work. There is suggestions of brightening clouds as well. I need to finish up. So carbon dioxide removal has some interesting potential implications. Planting trees has impacts, but it is probably minimal in terms of its harm, and actually significantly beneficial, has co-benefits in terms of improvements of ecosystems, as long as the planting of trees is diverse not monocultures trees. It is diverse tree cultures to rebuild natural ecosystems. We can also, by changing agricultural farming, by changing the way that we till the soil, you can probably increase the amount of carbon in soils. Ocean fertilisation likely has adverse impacts on ecosystems, but the really interesting one is solar radiation management. You can do it, other people can do it. Relatively inexpensively. You only need big second-hand aeroplanes, and they exist. There's a lot of second-hand 747s that you can rent. You can inject the aerosols into the lower part of the upper atmosphere, the stratosphere, and what does it do? Well, first thing is, if you stop, because you've got all the carbon dioxide, it warms rapidly. It reduces rainfall in the tropics in exactly the same way as volcanoes do. That leads to permanent drought, reduced rainfall in the tropics. Not a good solution if you live in the tropics. It changes the way that the distribution of rain and sunlight reaches the Earth, but the critical factor is increasing the amount of particles in the stratosphere causes increased ozone depletion because it creates over the whole of the atmosphere exactly the characteristics of the ozone hole over Antarctica, which is primarily caused because of ozone depleting chemicals having a catalytic reaction on the surface of particles. It will lead to significant global ozone depletion and it will kill people from extra skin cancer. You don't hear it talked about, but it's not clear that a solution that kills people while allowing more fossil fuels to be dug up and burnt is a good solution. Not in my view. But of course, it looks pretty in cartoons. There are many different adverse impacts from solar radiation management. It changes rainfall patterns. It leads to reduced rainfall in the tropics. It increases health impacts and skin cancer. And unfortunately, at the moment, there is nothing in terms of global or national governance that would stop anyone from doing this. It's not included in the UN Framework Convention. It's a bit like, well, it's scientific studies are looking at it and saying it's bad, but no one. There was a study by the Royal Society a couple of years ago that talked about governance, but there is no global agreements. This will be just as hard to negotiate, maybe harder than the Framework Convention on Climate Change. So let me finish. Climate has changed. Fortunately, we've fixed the ozone depletion problem. It's unlikely that Paris will fix human emissions of greenhouse gases so that we can avoid dangerous climate change. It was an important step on the way. But unfortunately, there is a temptation among some developed country governments and scientists to say that we could fix the problem by using geoengineering. And to me, that's the horror story. Paris is maybe good, maybe bad. Ozone depletion is the good news story. Thank you.
We'll take 5 minutes of questions now.
Yeah. So we've got time now for you guys to quiz me on anything you want. Well, preferably on what I've talked about. Read the book, I've reviewed the book. I think Tim is overly optimistic in terms of techno fixes, focuses on some techno fixes which he says will have low impact but will probably not be practical and avoids discussion of much of solar radiation management, which is being suggested. Tim's focus in his book is on geoengineering through carbon dioxide removal, and he tries to look at some techno-fixes, including freezing out CO2 in Antarctica. It's not as practical as he suggests. It's a very inhospitable environment. Or carbon capture through biochar, which hasn't been enormously successful in Australia so far. And many other people have said that the capability of quickly extracting carbon dioxide from the atmosphere and burying it in soils through agricultural practices or through biochar, Tim is overly optimistic. I think the latter. So it depends on what you call geoengineering. It is clear that there are some aspects of carbon dioxide removal, like planting more trees, like increasing carbon storage in soils, potentially even using algal ponds in saline ponds in ocean, in shallow water, to capture carbon dioxide, and then harvesting that and either using it for food or for fuel or just burying it underground. Those sorts of carbon capture solutions may work. They do have impacts, but we need to assess what the impacts are. Solar radiation management, either it will have minimal or zero impact. Discussions of planting roofs white is good. It actually cools the building, so that is good. I mean, that's why most Spanish buildings are white, and Australian buildings with black roofs or dark roofs are stupid. But actually, telling people in Australia that they're stupid doesn't win you friends. So, generally, I would argue that geoengineering is not good except where it's focused on carbon dioxide removal. So, most countries will officially tell you they're not considering it, but a somewhat independent-minded, very rich American injected iron filings into the North Pacific a few years ago and tried to sell the carbon dioxide credits associated with the reduction in carbon dioxide and produced more fish because of the slightly more fertile oceans. And he said he got permission from the indigenous Canadian population in the area. This was off the coast of British Columbia. So, you know, people are doing it and trying to make money out of it. It would just take a, how would I say, a Bill Gates or Al Gore type, not those people, type of person with a lot of money who wants to save the world with access to a lot of aeroplanes, and they could do it. There's no control. Ban advertising.
Is that the only way you can achieve lowering consumption?
Point out to people that by consuming more, they're destroying the planet.
But it's not working.
No, it hasn't worked. It will when people die. Sorry, when more people die. And we're going to hear about that.
And there'll actually be a chance to ask some more questions of David after the next couple of presentations on the panel. So thank you, David.